All right, it's time to introduce one of the most fundamental concepts in programming, and regardless of what language you use. In this case, we're going to be focusing on Java, but it doesn't really have to be. That concept is something called arrays. Now, arrays, what are they? They are basically a collection of data. Now, if we think about a variable like a bucket, an array is like a bucket as well, but instead of only storing one piece of information, it can hold many related pieces of information. There are a few catches to that. Okay, so the first and foremost, all of the data stored in that one bucket, that one collection, all have to be the same type. Now, the idea is that they're related by purpose. Technically speaking, they don't need to, but it would be silly not to do that. So, for example, I might have a collection of names, or I might have a collection of marks, or a collection of inventory items. It doesn't matter what it is, as long as they're related by purpose, and they all have the same type. So the example you see here is an array of 5 names: Jack, Judy, Jagmeet, Jade, and Jorge. Now, that's great, but that's not the only thing we can use it for. As I said, arrays are basically one of the most fundamental data structures and programming concepts we're going to learn. Now, we're going to learn many more over the next couple years, but this is still going to be the foundation for all of them. Now, an array acts, like I said, just like a regular variable, but we can maintain a massive amount of data all with a single identifier, a single variable name. This is going to give us a huge amount of power going forward. Well, what kind of power? Well, the power really stems from the idea of organization and quick access within that one container. We're going to be able to pull out the 73rd item in a container holding 712,000 items, and it's going to happen instantaneously. That's the best part. If we don't use arrays, think about that. Imagine if we wanted to store all the names of every student in the school. If we did that, we'd have to have individual variable names for each one of those. If we have 1,800 students in the school, imagine creating 1,800 individual variables. String, student name 0, string, student name 1, and so on and so forth. That's a lot of variables. Not only is that going to take you 1,800 lines of code to define, you're then going to have to build all the logic to retrieve and maintain that data. Or you could simply have one array that holds a collection of strings, and you can store all 1,800 of those names inside of that one collection. Now imagine writing the if statement that would be required to display a specific name from that collection based on the student number. How would you know? You wouldn't be able to just go to the right one. You'd have to check every single one. Are you student number 1? Are you student number 2? Are you student number 3? And if each one of those takes about 4 lines of code, that's over 7,000 lines of code to write that, just to display a name. With an array, we can do it in 1 line. And that's that instantaneous or direct access that we have. So you can almost think of an array kind of like RAM, where when we used RAM versus a hard drive, RAM is the idea of instantaneously getting to the point that we need to get to when we need to get to it, kind of like a switch statement. Okay, so this strength is actually only going to grow as we learn new concepts. The big one is loops. Loops are going to allow us to step through every single item within an array and allow us to analyze it or use it or process it in some way. And this is going to be very, very powerful going forward. Maybe we're searching for a very specific student or something. Maybe we want all the students that have the same last name, that kind of thing. So it'll allow us to scan through every single one of those, but more on that later. So now we got to break down this idea. What is an array structure? And let's talk about the terminology. First of all, when we think of arrays, we typically visualize them like a row of values. You saw on the first slide where I had all 5 names beside each other. Each one of these values we call an element. So that example that I showed you had 5 elements. There were 5 names that were there. The total number of elements in an array is called its length. When an array is created, its length has to be set, and it can't be changed. It's set in stone. The reason being is that it actually goes and reserves that much space in memory for that many items. And then if something else comes along and saves directly after that point, it'd be physically impossible for you to add another element there or another value because there simply isn't space anymore. So we have to understand the fact that it is set in stone and it can't really be changed. There are ways around that, but that is not actually changing the value. So each element of an array has an address. Kind of like when we talked about strings, how every character has an address. And similarly speaking, just like the string, we call each one of these addresses an index. Now, the plural of index, of course, is indices, although you may sometimes see it online as indexes, and mostly in American websites for the most part. So these indices, or these index values, are all numbered from 0 on. So the first element of the array is at index 0. The second element is at index 1, and so on and so forth. So up at the top of the screen here, you can actually see kind of all the terminology that we just talked about. So if you have a collection, that has a collection of 10 elements. So the array length is 10. The indices numbered from 0 all the way up to 9. That is what we call the range. The range of indices of an array is always the same. It's always starting at 0 and goes up to the length minus 1. That's why you see the length here is 10, because there's 10 items, but the last index is length minus 1, which is 9. And we also see the other references to the idea of element and whatnot, okay? Now, it's important to realize that if you ever try to use an array, using an index into an array that is outside of the range, so either less than 0 or greater than length minus 1, you're going to get what we call an out-of-bounds error. And your program will typically crash as a result of this. So, for example, going up to that first slide, if we, all the way back here, if we look at this, if I were to number each one of these, so let's say this is 0, 1, 2, 3, and 4, I can see that this array has a length of 5 because there are 5 elements. The range is from 0 to 4. Now, if I were to ask you a question such as, hey, what value is at index 3? You would say, oh, there's index 3, so that's Jade. Jade is at index 3. But if I were to ask you, hey, what value is at the third index? Well, that's something different because that's a relative term. The third is 1, 2, 3. This is the third index right there. So you have to listen to the wording. Am I saying at index 3, which is a specific number, a concrete value? Or did I say the third index? That's a relative position from the beginning. Okay, so let's move on here. So let's try and visualize working with an array. So let's imagine, for example, we're going to do a little bit of a story here. So let's imagine, for example, you want to go out to a nice dinner with your friends, and you're going to take out 4 friends. So there's 5 of you in total. So it's a fancy restaurant, so you can't just show up and hope to get a table. So you're going to call ahead. You're going to call to the restaurant. Maybe it's the Keg or something like that. That's about as fancy as I go. And you call and you say, "Can you please reserve a table for 5?" Well, what's the restaurant going to do? They are going to go set aside a table. They're going to set up 5 seats for you, and they're not going to let anybody sit there. So they're going to put a little sign on here that says reserved for whoever you are, okay? Now let's draw a little analogy for a second. So let's imagine over here is the door, and maybe there's the little hostess here at the front, whoever that is. The hostess over here, and this is our door. And maybe we have a window over here, which can go to the outside. Great. Now, imagine that there are 5 of you that are showing up. I'm just going to make up these names here. So what do we have? We have Jack. We have the same ones before. We have Jack. We have Judy. We have Jagmeet. We had Jade. And we had Jorge. All right. Now let's pretend that you are Jorge. And it's your birthday or something like that, and you got to make sure that you're the first one that shows up. And maybe over here, Jessie is the hostess. All right? So you come strolling by, you come walking in the door. You want to be the first one there. So you come in and say, "Hey, Jessie, thanks for greeting me, and I'd like to be seated at my table." So Jessie walks you over, and when you get to the table, you see that there are 5 available seats. Now let's pretend for a second. Maybe the kitchen's over here. Maybe the bathroom is over here. Why the bathroom is right beside the door, I don't know. Just pretend with me for a second, okay? So we have the bathroom over there, and you look at these. Let's number these seats just to make life a little bit easier so we can understand these things. So you want to be able to see everybody as they come in, because obviously it's your birthday and you're the one kind of organizing everything. So you sit down over here at seat number 2 so you can see everything from the opposite side. So Jorge sits right here. Awesome. Maybe a couple minutes later, so Jorge's already showed up. Maybe a couple minutes later, Jack and Judy come in together. Maybe they're a couple. Who knows? I don't know. So Jack and Judy come in, and they see Jesse at the door. Say, hello, we're with the Jorge party. And they're like, and Jesse says, no problem, come on in. And so Jack and Judy want to sit together because, maybe they're a couple. But they also don't want to be near the bathroom. So they're going to sit on the opposite side here. They're going to sit at seat 3 and 4. So maybe Jack is good friends with Jorge, so he wants to sit right beside him. And Judy over here sits down over there. So there's Jack and there's Judy. They're here now too. Okay, but you know what? Judy gets up and she says, I got to go to the bathroom for a second. So she gets out of her seat and she's over here in the bathroom. And then Jade comes walking in the door. Hey, everybody. Jade comes walking over the table, sees Jorge, sees Jack, and Jade sits down beside Jack so she can have a conversation across the table and not sit awkwardly directly beside somebody. So here comes Jade. And Judy comes strolling out of the bathroom with a not great happy look on her face. She sees that Jade is sitting beside her boyfriend. Uh-oh, that spells trouble. Judy looks over at Jade. That's my seat. Oh, sorry, says Jade. That was not my intent. So she jumps out, gets out of there, goes over to the other side. She's like, I don't want to sit directly next to the bathroom. I'm going to sit right next to Jorge. So here is Jade. Oops. Here's Jade over here. Oh, what happened to my Jade there? And Judy gets her seat back. Awesome. So we got everybody but Jagmeet. Jagmeet comes strolling in, says, I guess I'm by the window. Thanks, guys. So Jagmeet is over here. So they're all enjoying their time, and the food comes out, and all of a sudden, John goes walking by the window. John's a good friend of Jorge's, and he's like, oh my goodness, he waves through the door, and he comes through, and he says, hey guys. So we're going to turn this into John for a second. John says, hey guys, how you doing? And they're like, oh, pretty good. And then he's like, do you mind if I join you? And Jesse comes walking over here and says, sorry, we just don't have space for you. I wish we could, but we can't. Jorge looks very sad and lonely, but he understands. And John's like, no, I get it. So he goes strolling out the door and walking away. And he's like, oh, sad face. And he's going home because he didn't get to join the party. What you just saw there is an example of how we can interact with arrays. So first of all, we had to call and make a reservation. That's basically the same thing as defining an array. Because when we define an array, we have to specify its size. Great. We also gave it a name. This was the Jorge table. So it was reserved specifically for Jorge. Awesome. So that was basically us reserving the table. But at that time, all that space was being taken up, but nobody was actually even sitting there. It just was used. That's the way an array works. We consume the memory even if we haven't stored any data in there yet. As people started to come in, first Jorge came in, and Jorge sat at the table. That's like adding a value into our array. But you'll notice that Jorge didn't sit at element 0, at index 0. He went directly to index 2 because he chose to. Well, working with an array, we have direct access to any element that we want. We don't have to fill up in any order. We can go anywhere we want. And we also saw as Judy went to the bathroom, she left her spot, which made it available for Jade when Jade came in. Jade filled that spot. And then Judy came back out. Jade jumped to the other side over to index 1, and Judy went back to index 4. And we started to fill those up. Eventually, the array was full. And then poor John came in. And John said, hey, I'd like to join you. But unfortunately, arrays cannot be resized. Another seat cannot be put at the table. There just simply isn't room. We're not allowed. So John was turned away. And that's going to work the same way that our data does. We simply cannot add more values. We don't have to fill the table. Maybe Jagmeet didn't show up. And that seat just stayed open the entire time. That's perfectly reasonable too. Now, in that case, we're still consuming the space of 5 chairs though. So if this were an array, the length would still be 5, even though we're only using up 4 elements. So that can sometimes cause a concern because sometimes our data requires the entire number of elements that are actually being used, and other times we just need to know how big the array is. So this is all information we need to keep in mind. All right, so now that we know our story here, let's dig in a little bit further into our discussion on arrays. So first of all, before we can use an array, we have to define it. It works the exact same way as any variable. We can't create we can't use a regular integer or a string or anything like that unless we've defined it first. And of course, we know that defining a variable does a couple things. First thing it does is it adds it to the Java dictionary, so now it'll recognize it every time we use that identifier throughout the rest of the program. The next thing it does is it reserves that space in memory. And for an array, it reserves a big chunk. It reserves enough space. So for example, if it were an array of 5 integers, it reserves enough space for 5 integers right beside each other in RAM. That's super important to realize. Now let's go over to how we go about doing this. If you recall, in order to create just a regular variable, the only thing we need is a type and an identifier. So if I wanted to create an integer called num, it would just be int num. Great. We can even initialize its value if we know it immediately. So we could say int num equals 7, and that not only defines it, reserves the memory, it also fills it with a value at that moment. Defining an array, it's pretty much the same, except there's 2 changes. 2 little changes. First thing we need to do is we need to realize that because we're holding a collection of data, we want to pluralize our names, typically, right? So for example, if I'm, instead of creating int num, I'm going to create int nums. Now, there is some exceptions to that rule. Maybe I have an array of moose. Well, what's the plural of moose? It's moose. So I really don't want to call my array mooses, right? It doesn't really make much sense. And for example, if I have a whole bunch of persons, I don't want to call it persons. I want to call it people. So you got to think through the name as much as you possibly can. So the first thing is the name needs to be pluralized. It follows all the other standard naming rules for variables, camel case, and that kind of stuff. The next thing we need to do is we need to tell the compiler when we're defining it that it is actually an array and not just a regular variable. And we do that using 2 square brackets, an opening and closing square bracket, right between the data type and the name of the variable. So we see here int square nums. You see that right here, int square nums. Great. So once we've done that, the next thing we have to do is that defines it, but it hasn't actually initialized it and reserved the memory yet. Not yet. The next step will actually reserve the memory. That first step simply adds it to the dictionary. So the second step is going to go reserve the memory. We have to tell it how big it is in size. So you can see this line, nums equals new int 5. What that's saying is there are 5 elements, 5 empty elements in this array because nothing's been stored there yet. So that means that it's going to have a range from 0 to 4. 0 to 4. So 0, 1, 2, 3, 4, that's 5 elements. We can combine these 2 steps, which we normally will do. There's only rare circumstances where we're going to split those steps up because maybe we need to create an array, but we're not sure how many elements there are yet. Maybe we get that from the user. Maybe we calculate it or something like that. And that may be determined while the program is running as opposed to while we're coding the program. But most of the time, when you create an array, you're almost always going to know how big it is. So typically, we're going to combine the 2. So there's our int square bracket nums. Yes, this is an array equals new int 5. So this is going to create an array of 5 elements with a range of 0 to 4. But again, there are no values in there right now. It's just consuming the memory, 32 bits times 5. All right? So 160 bits of space at this point. Plus a little overhead that you don't really need to realize, but there's a little bit. So how do we actually access the data inside of the array? How do we retrieve the data? So let me draw an analogy for you for a second. Imagine that you want to order a pizza, and the delivery driver has to bring that pizza to your house. How does that work? How do they know where you live? Well, when you order that pizza online or over the phone, however you do it, you have to supply them with 2 very important pieces of information. You need to supply them with what street you live on and the number you live at. Well, that's the same thing as an array. So if this is an array called nums, nums is like the street. And the index that you want to store it in, so maybe I want to put the value 5 right there, I am putting it at index 2. The index is like your house, the house number. Okay, so you have to specify the name of the array as well as the index in order to properly access a given element of the array. And we do that with the square bracket notation. Okay, so for example, if I wanted to access index 3 of an array called names, I would say names square bracket 3. And the way we read that is we read it like this: names at index 3. But that's too long. Typically speaking, we just say names at 3. Much easier to do. So that's names at 3, but it really means names at index 3. Now, that's me putting a literal value in there for the index. It doesn't have to be a literal value. It could be a variable. In this case, you see me using a variable called student number. Whatever student number is, it just has to be within the range. Remember, 0 to length minus 1. So however big that range is, student number better fall inside of that, or you're going to get an out of bounds error. You could even put an entire expression there. Here we see me doing student number minus 2. Maybe I have a student number, but I need the person that's 2 before that student number. So this is an entire expression. So it's going to evaluate this entire expression before it tries to access the elements of the array, brackets first, right? Over here, this last one, you see me actually calling a function. So this get student number is probably a function that maybe asks the user for a student number, converts it to an integer, and then returns that value back. So it could be doing all of that work in the meantime while you're trying to access a specific element of the array. So whatever we put inside of here has to be an integer, and it has to be within the range. Outside of that, there's no other rules. That's it. So this will retrieve, or this will access. I don't want to say the word retrieve because we may be doing something else. So this will access a specific element of an array. So how do we actually assign or store a value in an array? It's pretty much the same as it was with a standard variable. If we think about how we did that, we just said, well, our variable is on the left, so that's our where, and our what, or the value, is on the right. Now this could be an entire expression or whatever we want, but the key is that whatever's on the right-hand side is going to get stored in the location on the left. Well, working with arrays is exactly the same, except when we specify the array, we have to specify which index we want to store it at. So this is storing the score 1000 in an array called scores at index 2, specifically at index 2. Great. What if you wanted to set all the elements in the array to the same value? What if you had an array of like 10 items and you want to set them all to a value of 0? Or maybe you wanted to set them all to different numbers. How do you do that? How would you do this? Well, unfortunately, there's no easy way to just set all the elements of an array to a single value in Java. There are in a few languages like Python, things like that, but not in Java. Most languages don't actually have that ability because of the way the arrays are maintained and stored. So we actually have to do it the hard way. We have to manually do it one piece at a time. So that means I would have to do something like scores at 0 equals 0. Scores at 1 equals 1. Scores at 2 equals, or 0, sorry. Scores at 2 equals 0. Scores at 3 equals 0. All the way up to scores at 9 equals 0. So it would take me 10 lines of code to do that. That's not great. Not even ideal. So I wonder if there is a better way. Well, let's recall for a second that if we know the value of our variable, a regular variable, we can actually store that value when we define it. So in this example, I'm storing the value Athena in the variable called name, which is a string. So this is me defining it and assigning it or initializing it at the same time. No problem. We can actually do the same thing for our arrays as well. So as I said, normally we would just say, let's say, for example, I was creating an array of 5 high scores. Normally we would define that array like this. We would say, okay, int square bracket high scores equals new int 5, because I have 5 elements. And then I'd have to go through one at a time. Let's say I want to set them all to a value of 0 because the game hasn't been played yet. Great. So I would say high scores at 0 equals 0. Then the next one would be high scores. These would all obviously be on their own line. High scores at 1 is equal to 0 as well, and I'd have to do that for all 5 elements. Okay, that's fine when there's 5, not fine when there's 500 or 5,000 or 5 billion. Nobody wants to do that. But fortunately, we can at least combine these two steps, just like we did with a regular variable, we can actually combine these two steps with an array as well. There are a couple differences. So you see that the very beginning is still the same. I'm still defining the array int square bracket high scores. I still have to say equals new int, which says I'm specifying that this is an array of integers, but you'll notice this time there's no size. No size. We don't have to specify it because right after this, I guess I don't have any erase option here. Right after this, I'm actually going to list all the values of the array. In this case, I listed 5 elements and they're all 0. But because I listed 5, it will count them and it will set the size for me. I don't actually have to specify it. So I just have to start listing off the values. So this will create an array where every single value, 5 of them specifically, all has the value 0. Great. Okay, so just a couple points. As I said, we don't need to specify the size. We do need to specify each element's value. Now here I set them all to be zeros, but they don't have to be. We can actually set those values to anything that we want. They don't have to match, but they can if you want them to. That's completely up to you. So let's take a look at a small program for an array. Maybe that'll help put things together for you. Imagine I had that array of high scores. We'll make it a little bit different though. All right, so here I'm going to create an array, high scores, and it's going to have the values 1,000, 900, 800, 700, 600. And that is just an array of 5 elements. Now imagine I want to display those 5 elements on the screen. Well, one at a time, I have to access each element, so scores at 0, scores at 1, scores at 2, and display them. So my first line of code might look like this. System.out println 1 : high scores 0. So that's going to actually display the value. That's actually going to display this. It's going to say 1 : then a space because there's a space there. And then it's going to retrieve the value of high scores at index 0, which is 1,000. So it's going to look exactly like that for that first line. Now I'm going to do it for the next 4. Oops. And we get something a little bit cleaner that looks like this. So we get 1 : 1,000, 2 : 900. So that's pretty good. Wasn't that much work. Now, of course, there's only 5 elements here. If I had 5 billion elements, that would be a lot more work. But that's where loops come in later on. And that's going to make our life super duper easy. So to summarize, what we learned here in this part of the lesson is that we can define a collection of objects or a collection of values that are related by purpose and have the same data type, and that collection is called an array. That array takes the place of many, many, many variables in a single container. We have the ability to define it as any size we want. That size is set in stone though, we can't change it. We have the ability to access any element that we would like using the square brackets. We have the ability to specify the values of the array when we define it, if we know it. And we have the ability to change those values at any time. Not just retrieve them, but change them. And that's pretty much it for now. And from here, we're going to move on, and in the next lesson, we're going to start applying it in a little bit more complex ways, and you're going to see some more interesting ways that we can deal with this code. Fun.